Hey guys, and welcome back. So we've gone through the process of kind of configuring everything that we need to do to install the Autoscaler on a EKS cluster. Of course, the directions are going to be different if you're using a different cloud vendor, but now that we've got everything set up, we can go ahead and test it out. So how do we test out the cluster Autoscaler component? Well, right now, if we run kubectl, let's say kubectl get nodes, we should see a couple of nodes in our cluster. Sure enough, here they are. However, we don't really have any workloads running on those nodes at this point. We haven't deployed any applications. So what we can do is provision a deployment controller, like what we did on the earlier demonstration, to actually scale up a whole bunch of nodes on the cluster. However, we need to configure those pods in that deployment spec to use a certain amount of resources. So I'm going to fire up Microsoft Visual Studio Code here, and we're just going to define a Kubernetes deployment manifest here. So let me go ahead and configure this, and I'll give it a name like some cool application. And under the spec for the pods here, you have the limits section here for the pods that sets a certain amount of limits on CPU shares and memory for each pod. So I'm actually going to bump this up to maybe, let's say 256 megabytes each, and we'll say maybe 400 CPU millishares per pod. And then I'm going to just spin up an Nginx container image here. We'll expose it on, let's say, port 80. And that should work pretty well for a pod spec. But now what I'm going to do is add in the replicas property here. And let's start out with replicas of something like 4. So I'll go ahead and just hit save, or well, let's actually just copy this to my clipboard. And then in my shell here, I'll go ahead and just paste this in. And then I'll do a kubectl apply, namespace, default, and then file name, just a dash. So that's going to give us 4 replicas of an application. Let me do a kubectl get all namespace default here, and we should see that our deployment controller and a bunch of pods and a replica set have been created. And sure enough, there it is. And it looks like it's downloading the Nginx container image, so we'll give that just a second to run here. And now we've got 4 pods up and running here. So let's check our nodes and see what's going on. So I'll do a kubectl get nodes once again, and we still just have these 2 nodes running on the cluster. So let's check our auto-scaling group. So if we head over here to the console, go to EC2, let's check the size of our auto-scaling group for this cluster. So I'll head down under auto-scaling groups right here, and as you can see, this auto-scaling group still only has 2 instances in it. It has a minimum capacity of 2 and a maximum capacity of 20. So now that we've created those 4 replicas of those pods, it seems like that hasn't stressed our infrastructure enough to actually require the cluster autoscaler to do any kind of scaling activities. And we can kind of verify that by running kubectl logs on the deployment controller, or actually the pod for it. So let's do kubectl logs. Let's do get pods from the namespace kube system. And then I'm going to find the pod ID for the cluster scaler and just copy that to my clipboard. And then we'll do a kubectl logs namespace kube system. And let me do pod / pod name. And once we do that, we should get all the logs from the cluster autoscaler component. And it's kind of a lot to look through here, but what you're going to see is on the timestamps right here is that essentially every few seconds it's going to go ahead and just evaluate the current configuration of the cluster and see if there's enough resources to satisfy it. So you can see 49, 59, 09. So every 10 seconds approximately, it's going through and just running an evaluation to see if there are any pods that are unschedulable because there's not enough capacity in the cluster. And it's basically decided that we don't need to worry about scaling up because we don't have any pending pods and we're not reaching any limits here. But what if we were to scale this deployment controller in the default namespace and increase it to, let's say, maybe 10 replicas instead? So I'm going to grab this deployment here, and we're going to do a kubectl scale. So kubectl scale, and then specify the deployment controller in the default namespace, and then we'll set replicas equal to, how about 10? So we'll go from 4 to 10, and if you recall from our pod spec that we created right here in VS Code, we have 256 megs of RAM for each pod as a limit, 400 millishares of CPU as a limit as well. However, we don't have the requests property in here, so there's no kind of minimum amount of resources that these pods are going to be requesting. So they're basically just going to use as much as they need up to these limits. But if we really want to stress this cluster, let's do a get all again here and see if we have 10 pods now. If we really want to stress this cluster, what we can do is specify a minimum number of system resources for each of these pods. So you can see it looks like at least 8 of these pods are up and running, and it looks like actually having 10 pods might actually have triggered an auto-scaling event. So let's take a look at our logs here and just see what's happening. And let's look for a scaling event. We have scale down status. And it looks like right up here, you start to see the logs are starting to look a little bit different. And sure enough, right here, it says estimated 1 nodes needed in this kind of randomly generated auto-scaling group name. And so it creates this plan to essentially scale the auto-scaling group, and it's identified 2 pods as being unschedulable. So the reason that it's going to scale up the auto-scaling group is because it's determined that there are 2 pods that are unschedulable because there are inadequate system resources. And so what you're going to see here, it says expanding node group, and it's going to say, what is the best option to resize the node group? And it's going to say, I think I need 1 node in order to satisfy these 2 unschedulable pods right up here. And so it's basically going to perform the scaling event. And right down here, you can see it says it scaled it up to 3 nodes. So if we were to head back to our kubectl command line utility here, do kubectl get nodes, that will be the way that we can confirm that a new node has been provisioned. And as you can see, we now actually have 3 nodes reporting into the cluster, and this node right here is only 68 seconds old, so we know that this node was just added into the cluster. Another way that you can confirm that is just to take a look at the console once again, and we'll just refresh the auto-scaling group right here, and now you can see that the cluster autoscaler has indeed increased it to 3 instances. And now that it's increased the capacity, we should have all 10 of these pods in a running state. Now, if you're struggling to kind of stress the cluster, you could go back to your pod spec here and actually set the requests property and set basically a minimum number of system resources. So for CPU here, we could say, I want you to have at least 400 millishares, and for memory, I want you to use at least 256 megabytes of memory. So you could add this in there and make it a minimum, but it looks like we were able to actually accomplish that without having to set requests just by increasing our replicas up to 10 pods. I hope this has been informative for you, and I'd like to thank you for viewing.